some few basics from our electrical circuits. So coming to the concept, what is meant by an electrical circuit? I think you know better. And what is meant by an electrical network? You know better. For example, if you have a voltage source and you have an combination with a resistor like this forms a single closed path. This single closed path is called as an electrical circuit. Like this, if you have one more electrical circuit consisting of a resistor and inductor, this will form one more closed path with a current magnitude of I2 and here with current magnitude of I1. I'm going to call this as an electrical circuit 1, which forms a single closed path with active elements as voltage source and passive elements as resistor R1 and resistor R2. Similarly, this is going to form a closed path with a current magnitude of I2 with a resistor of R3 and an inductor of L1. So this is going to form an electrical circuit 2. So what is meant by an electrical network means a group of electrical circuits is called as an electrical network. So this is the basics of what is meant by an electrical circuit, what is meant by an electrical network. Let's have some basics revision in this session. So we'll try to understand what is meant by an voltage division rule, what is meant by current division rule with respect to the numericals. So coming to the first concept, let's try to understand voltage division rule. Voltage division rule, and this voltage division rule is applied for series resistance or series circuit. For example, let us try to consider a circuit diagram. So here you have an voltage source of E and here I have an resistor of R1 and here I have one more resistor of R2 which forms an closed path. This is resistor R1, this is resistor R2. So when the current is entering, the polarities are positive. Okay, whenever the current is entering, the polarities are positive. Current is leaving, the polarity is negative. Similarly, the same current is entering here, the entering terminal is positive, the leaving terminal is negative. Let's try to apply an Kirchhoff's voltage law to derive the expressions. So now our intention is to find out the voltage at R1 and voltage at R2. So here I am labeling this voltage as V1 across the resistor R1 and this voltage as V2 across the resistor R2. Let's try to apply the KVL. So when you apply the KVL, the current is leaving, or the leaving polarity of the voltage? Positive. So this is plus E, and current is leaving here, or the leaving polarity of the current? Minus. Minus, you have to write down the drop where the formula for voltage is V is equal to I into R. So what is the current in the branch? Already we have taken the current in the branch is of I amperes. So minus I into R. What is the resistor in this branch? Into R1. And once again you can see here the current is entering at positive terminal and current is leaving at negative terminal. You are going to get a minus polarity here, minus drop. So what is the drop? I have to write down as expressed in the form of current into resistor. What is the amount of current? We had considered it as I into R2. So where R2 is the next resistor, that equal to 0. So this is how we apply a Kirchhoff's voltage law. So coming to logic here, so I want the value of so I can write down this E is equal to I into R1 plus R2. So now what is the total current in the circuit? I can be written as E minus 0 divided by R1 plus R2. Now try to understand that this is the total current in the network. So now we want to apply the voltage division rule. So I am redrawing the circuit. So this is the total voltage E, and here you have a resistor R1, here you have a resistor R2, this is resistor R1, this is resistor R2, and here I am getting a voltage of V1 and here I am getting a voltage of V2. So now my intention is to find the value of V1 and my intention is to find the value of V2 by applying voltage division rule. Now let us try to find out V1. So what is V1? V1 is the voltage across R1. Voltage across R1. So what is the voltage across the R1? I can write down. So how to write down the voltage across R1? I can write down it as I into R1. You can see here what is the voltage across V1. So I can write down it as I into R1. So how to write down I? I can be written from this formula. I can write down this as E divided by R1 plus R2 multiplied with R1. So further I can write down this also like this, where E is called as a total source voltage. Total source voltage divided by into, so R1, where R1 is nothing but where we require voltage. So here we require the voltage. This is nothing but resistor in series where we require the voltage, okay, divided by the sum of resistors which are connected in series. So here you can see that the current is constant throughout the loop. I can say that I1 and I2 are connected in series. So what are the resistors connected in series now? R1 plus R2, where I am calling this R1 plus R2 as this is the sum of resistors connected in series. So this is the formula of voltage division rule. So what is the formula of voltage division rule? I can summarize like this. Total voltage. What is the total voltage? Is nothing but E multiplied with. So here I require the voltage. What is the resistor at this voltage source? R1 divided by the sum of resistors which are connected in parallel. So similarly, I can find the voltage across V2. So what is the voltage across V2? Voltage across V2 is nothing but voltage across the resistor R2 is equal to, how I can write down it as the current I into R2. From here we already applied an KVL, we are very clear. So this is nothing but the voltage across R2. So that is equal to, what is the formula of I? Already we had done it, which is E divided by R1 plus R2 into R2. So how to write down this formula? Where E is nothing but the total source voltage, where R2 is nothing but resistor where you require the voltage in the series branch, divided by the sum of resistors which are connected in series. So I can write down as the same formula what we have, where E is called as the total source voltage, where R2 is called as the series resistor where you require the voltage, divided by the sum of resistors which are connected in series. To understand this, we will try to do one problem. Let's try to take first numerical, solve it. So coming to the first problem, so we have an electrical circuit given to us like this. So this is the voltage source, and this is nothing but resistor 1, resistor 2 and resistor 3, and the given voltage is 60 volts, and you have an given resistor is 6 ohm, 9 ohm and 5 ohm. I can say that the current is entering in all these three resistors. The current flows across 6 ohm, 9 ohm and 5 ohm. I can say that 6 ohm resistor, 9 ohm resistor and 5 ohm resistor are connected in series connection. They are connected in which connection? Series connection. Why? Because current is constant. There is no division of current. So the current is not dividing. Since the current is not dividing, I can say that current is constant. All 6 ohm, 9 ohm, 5 ohm are connected in series. Now let's try to apply our formula. So what is, so the given problem is find V1, find V2, find V3 for the circuit shown. So we have to find V1 value, V2 value, V3 using voltage division rule. So already you are very familiar about this voltage division rule. Let's try to recall it. Total source voltage multiplied with the resistors connected in series divided by the sum of R which are connected in series. So coming to the same logic here, So now I want to find out V1. V1 is equal to, what is the total voltage or the source voltage? 60 volts multiplied with, so resistor, here we require the V1. So across V1, what is the resistor connected? 6 ohms divided by the sum of resistors which are connected in series. So what are the resistors which are connected in series? 6 ohm resistor plus 9 ohm resistor plus 5 ohm resistor. You try to perform the calculation, you are going to get it as 18 volts. So what is the V1 value? Here you are going to get 18 volts. So similarly try to apply to find out V2. So what is the source voltage given for us? So what is the source voltage? 60 volts multiplied here. So where is V2 here? Here the V2. What is the resistor associated with V2? It's nothing but 9 ohm. 60 into 9 ohm divided by the sum of resistors which are connected in series. What are those resistors? 6, 9 and 5. So 6 plus 9 plus 5. So when you perform the multiplication, you are going to get it as 27 volts. Let's try to find out the next one. So here we are going to get it this as some 18 volts. Now let's try to find out V3. So V3 is equal to the source value given to us 60 into, what is where we require V3 is across which resistor? 5 ohm resistor. 60 into 5 divided by 6 plus 9 plus 5. When you perform the multiplication, you are going to get it as 15 volts. Now try to cross check the things. Okay. So given source voltage is how much voltage? 60 volts, and a resistor is given, we already found out that value, and one more resistor is given, and one more resistor is given. We already labeled this as positive, negative, positive, negative, positive, negative. And what is the voltage developed here? V1. And what is the voltage developed here? V2. And what is the voltage developed here? V3. Now try to apply the KVL, whether our answer is correct or not. When you apply the KVL, the current is entering as I amperes, entering is positive, leaving is negative. Again the current is entering terminal is positive, leaving terminal is negative. Entering terminal is positive, the leaving terminal is negative. It's already marked as per the given sources. So let's try to apply the Kirchhoff's voltage law for the circuit shown below. When you apply the Kirchhoff's voltage law, the current is leaving. What is the voltage at this point? We have 60, and what is the polarity? We have positive. Okay, plus 60 volts minus. You see here the current is leaving. Whenever the current is leaving, what is the leaving polarity? We have minus. Minus. You have to write down I into R. Already I into R is already performed. And what is the value of V1? Which is 18 volts, which is 27 volts, where this is 15 volts minus 18 volts. 18 volts. So next current is leaving here. What is the leaving polarity of this voltage source? Minus. And what is this drop? Minus 27 volts minus. You see here the current is leaving. What is the leaving polarity we have? Minus. So that's why again a minus here. Minus V3. What is this V3 value? Which is nothing but minus 15, that equal to 0. That equal to 0. So you are going to get it as a 0. So when you solve it, 60 is equal to 18 plus 27 plus 15. You add all the values, you are going to get 60 volts is equal to 60 volts, where the Kirchhoff's voltage law is verified. Where I can say that this 60 volts is nothing but the voltage source. All these are nothing but the voltage drops, where the remaining three are nothing but the voltage drops. The Kirchhoff's law is verified. Algebraic, voltage sources is equal to voltage drops, or algebraic sum of all the voltage sources and voltage drops is equal to 0, where the Kirchhoff's voltage law is verified. So this is how we find the values of V1, V2 and V3 for a given circuit where 6, 9, 5 are connected in series connection. Let's try to do an second numerical. So coming to the second numerical, so an voltage source is given like this, and a series resistor 1 is given, one more resistor is given, and the applied voltage is 20 volts, and this is 2.66 ohms, this is 1.33 ohms. So now we need to find out, so let's try to find out V1 across this one and V2 across this resistor. Already we know that the current is flowing like this. Whenever the current is flowing, the entering terminal is positive, the leaving terminal is negative. Entering terminal is positive, the leaving terminal is negative. So whenever the current is leaving, what is the leaving polarity voltage? 10 volts. So let's try to apply the voltage division rule, and let's try to find out V1 and V2. So what is V1 value? Total voltage. What is the total voltage? 10 volts is the total voltage, into where we require the resistor. What is the resistor where we have R V1, which is nothing but 2.6. 2.66 divided by, so the sum of resistors which are connected in series, you can see here the current is constant and there is no division of current. I can say 2.66, 1.33 are connected in series. This is going to result 2.66 plus 1.33, where this will give an value of 6.66 volts. Now coming to the next step, we need to find out V2. So how to find V2 from the problem? So V2 is source voltage. What is the source voltage given to us? 10 volts, and V2 is across this branch. So what is the resistor at this branch? Into 1.33 volts divided by the sum of resistors which are connected in series, which is 2.66 plus 1.33. If you perform it by using your calculator, then you are going to get it as a 3.33 volts. Just directly by cross checking you can understand. Let's try to apply whether we got the correct answer or not. So the given circuit is like this, which is an 10 volts and a resistor R1 and one more resistor R2, and what is the voltage developed here? Positive, negative, positive, negative. So this is of 6.6 volts, this is of 3.33 volts, 6.66 volts. So now try to apply the KVL. Current is entering. Okay. So here the current is entering at positive terminal, negative. Already the voltage polarity are marked. There's no need to worry. So what is the voltage at this point? 10 volts. So current is leaving. What is the leaving polarity of the voltage? 10. So plus 10 volts, and current is leaving. What is the leaving polarity? Minus 6.66, and once again the current is leaving. What is the leaving polarity? Minus 3.33 volts, equal to 0. You transfer these negative polarities to the right hand side. Therefore 10 volts is equal to 6.66 plus 3.33 volts, where 10 volts is equal to 10 volts. You can see that our answer is 100% verified, where this 10 volts is nothing but a voltage source, where this 10 volts is nothing but the voltage drop. So both voltage source and voltage drops are verified. So this is how we have the of application of Kirchhoff's voltage law and application of voltage division rule. Hope the lecture is very useful. If you feel the lecture is very full, please like, share and subscribe our YouTube channel with the name kvthulasi. So thank you. So we'll continue the next session with current division rule. Thank you.